All right, we're back with homework number 2, take 2. All right, when you have a 5 inside of an integral symbol like this, we might want to write that 5 out in front. And now we have the e to the 5x dx. This should, at this point in your u substitution experience, lend itself to letting the u equal 5x and the du equaling 5 dx. We're going to bring that 5 to the other side. This is 1/5 du is equal to dx. Notice, as we go through this, we now have the 5x being replaced with a u, and we have the dx being replaced with a 1/5 du. This is going to be 5 times the integral of e to the u du, and we're going to have that 1/5 there as well. So this is the same as the integral of e to the u du. So we have e to the u plus c. Our answer is e to the 5x plus c. Now remember, we can always, to check ourselves, just quickly, if we want to check, we can check and say, if I take the derivative of that, do I get back to where I started? And indeed I do when I do that. All right. I'll do the next one a little bit more quickly. U is equal to the 2x minus 1. Our du is equal to 2 dx. dx would then equal 1/2 du. So we can now do our u substitution. So this is the integral of the square root of u. We have a 1/2 and we have a du. So the 1/2 and the du are replacing the dx. So that's being replaced by the 1/2 du. And the square root of 2x minus 1 is now just the square root of u. We have the 1/2, the integral of u to the 1/2 du. This is going to be 1/2 u to the 3/2. We can put that 2/3 out in front. Boom, boom. This is 1/3 square root of u to the 3rd, which is 1/3 the square root of 2x minus 1 to the 3rd power. All right, good job. Okay. Oops. All right, our next problem, we have the sine to the 3rd of x, cosine of x dx. Notice quickly that if we let the u equal the cosine x, our du would be negative sine x dx. And that, or excuse me, negative sine x dx. That doesn't do much for that sine to the 3rd, does it? So instead we're going to let the u equal the sine of x. And so du will equal the cosine of x dx. And we can rewrite letter c as the integral of u to the 3rd du. When we evaluate that antiderivative, we get 1/4 u to the 4th plus c. This is 1/4 sine of x to the 4th plus c, or you can write that as sine to the 4th x plus c. That's an indefinite integral, so we need that plus c. Our next one, u equals t squared plus 2, du is equal to 2t dt. T dt is a 1/2 du. So I'm going to have the integral of our t dt, so this and this, is going to be replaced with a 1/2 du, and we're going to have a square root of u here. So we can rewrite this as 1/2, the integral of u to the 1/2 du. This is 1/2 u to the 3/2 over 3/2. That's 1/3 t squared plus 2, excuse me, to the 3/2. Okay. Next one up, tangent squared, secant squared. Let's let u equal tan. Remember, one of these is going to be the derivative of the other. There's our secant squared x dx. It popped up for us, so this just becomes u squared du, or u to the 3rd over 3 plus c, which is just the tangent of x to the 3rd over 3 plus c. We can let our u equal 6 minus x to the 3rd. The du will equal negative 3x squared dx. X squared dx is equal to negative 1/3 du. And now we can rewrite this x squared dx is going to be replaced with the negative 1/3. I'll just bring it right to the front in the du. And this is going to just be u to the 4th power. So it's negative 1/3. 6 minus x to the 3rd to the 5th over 5, and I'll just write that as a negative 1/15. All right, our next one, we're going to let the u equal 1 plus x to the 3rd. du will equal 3x squared dx. X squared dx is equal to 1/3 of du. 1/3 of 1 over u squared du. Right? So we can now handle that. That's u to the negative 1 over negative 1 times 1/3 plus c, or negative 1/3. Put this 1 plus x to the third down in the denominator, plus c. And I'll do the last one for you, and then just have it on. Alright, so I just did that last one for you. You can pause the video there and double check your answer. Now we're evaluating some integrals. So the back side is the same exact stuff we were doing on the front side. It's now just evaluating integrals. So we're going to change our bounds of integration. Okay, I'll do I'll do A, D, and E, and then I'll write in the answers for the rest, and you can check those. So when I'm looking at this, again, I want one piece to be the derivative of the other piece. So notice that this x is the derivative of x squared, or at least a part of it is. So we're going to let our u equal x squared plus 1, and our du will be 2x dx. Notice here, here's my 2x dx, that's it, that x dx. There it is, that x dx. What does that x dx equal? That x dx is equal to 1/2 of du. And so let's rewrite here. This is the integral, and I won't put the bounds of integration in yet because those are going to have to change as well. I can put the 1/2 out in front, and I can put this u to the third power, and I'm going to have a du. I'm going to change my bounds of integration now. These bounds of integration are written in terms of x, but now everything down here, everything down there is written in terms of u. Right? So everything down here is written in terms of u, so I need to change these bounds of integration to go along with the fact that there were x's up here. I need to make them u's down here. So this is going to be 2, and this is also going to be 2. Now, we have a little bit of a get out of jail free card here because we're taking the integral, or the area underneath the curve, from 2 to 2. We haven't accumulated any area if we've just gone from 2 to 2, so our answer here is just 0. And we can just kind of do that quickly. We don't have to actually plug everything in. If we took the antiderivative, plugged in 2 and plugged in 2 and subtracted them from each other, you're just going to get 0. Let's do, I think I said I would do letter D as well. So let's go ahead and do that. Here in letter D, we're going to let our u equal the 1 plus the square root of x. This one might be a little challenging to see. You might have to play with this a little bit. But in general, as a general rule of thumb, choose your u to be the thing being put to a power. It doesn't always work, but it usually works. Our du then will be 1/2 x to the negative 1/2, or 1 over 2 times the square root of x. Now notice, here it is. There's your 1 over the square root of x dx. All right, and I should have written this as a dx for you as well. But hopefully you notice that that 1 over the square root of x dx is right here. That's the 1 over the square root of x dx. So I can say that 2 times du is equal to 1 over the square root of x dx. So let's start to rewrite this. Again, I won't put in the bounds of integration yet. We're going to have a 2 du. So I'll put the 2 out in front. I'll put a du here. And then this 1 plus square root of x is down in the denominator. This is just going to be 1 over u squared, or u to the negative 2. So let's rewrite this with the bounds of integration now. This is u to the negative 2 du. Again, these bounds up here are in terms of x. I need to rewrite them in terms of u. So this is going to be 2, and this is going to be 4. I just simply plugged the 1. All I did is I plugged the 1 in for this x. 1 plus the square root of 1 is 2. And I plugged the 9 in for the square root for the x. 1 plus the square root of 9 is 4. Now I can go ahead and evaluate this integral. This is 2 times u to the negative 1 over negative 1. I'm going to evaluate that at 2 and at 4. Someone asked a good question today whether the 2 should be implemented into both or whether you should wait till the end. It doesn't matter. You can either implement it in both. That's really just using the distributive property. Generally speaking, I like to do just this piece. Just plug those in and then multiply it times 2. So this really is the trees now. It's really easy to get a little confused here. But it might be easier if we write this as negative 1 over u. So this is negative 1/4 minus a negative 1/2. That's a positive 1/4. And I still have to multiply that whole thing times 2. So our answer here is 1/2. And finally, let's do letter E, and then I'll write in the rest of the answers for you. Here our u is going to be 1 minus x. Our du is going to be negative dx. So there's my dx. My dx is equal to negative du. So when I rewrite this, it's going to be an e to the u du. I'm going to have a negative sign out in front, and I need to rewrite this as from 0 to negative 1. All right, that 1 minus 1 is 0. The 1 minus 2 is negative 1. I can actually flip this, make it negative 1 to 0 of e to the u du, and take away the negative sign. And this is just e to the u evaluated at negative 1 and at 0. So this is e to the 0 minus e to the negative 1, or 1 minus 1 over e. All right, I'll do the rest of them and put them in.